Hello friends, in this video we will talk about ACID transactions as it relates to distributed databases. What is ACID? In distributed databases, ACID is an abstraction layer to provide certain guarantees for its clients. It's an acronym for atomicity, consistency, isolation, and durability. It provides useful guarantees, but it has a performance cost. Now, broadly, there are two categories of databases, SQL and NoSQL, which is also an acronym for not only SQL. Now, traditionally, SQL-based databases have provided ACID guarantees. What they do is they allow developers to focus on their applications rather than managing data properties and error handling. However, there is a performance cost of providing such guarantees, and with the modern day highly scalable applications, NoSQL DBs have found traction since not all applications require ACID guarantees. Nevertheless, ACID databases continue to serve a large user base because of its simplicity in use and because they provide a convenient programming model while providing data integrity that allows its users to reason about data in a meaningful way. Not only SQL databases, they do not provide ACID guarantees. What is atomicity? It's an ability to abort an entire transaction altogether due to an error occurring in a one or more requests in a transaction. What is a transaction? A transaction is a group of writes or read requests. Now, whenever a group of requests it arrives to a database from various clients, what the DB query optimizer does is it groups them together. It first of all checks whether a particular query is dependent on another query, and then it groups them together and then runs them through the transaction manager. What transaction manager does is it makes sure that either all the queries fail or all the queries succeed. So so in this way, the atomicity prevents database from going into an unpredictable state by not allowing an operation to be only partially committed. Either the entire transaction succeeds or the entire transaction fails. What is consistency? It's the ability to allow applications to specify invariants to always be satisfied at the end of any given transaction. Databases provide consistencies in different ways, like allowing applications to specify uniqueness constraints or allowing them to specify various range of the values. And so if any particular update to the database, if it doesn't meet those constraints, those updates fail. In this way, applications can make sure that their data based on their application logic is always consistent. Now, they could always explicitly check for these inconsistencies and fail their transactions, but that's an additional work, and thus DBs provide such a guarantee to simplify developers' task. What is isolation? Isolation is the ability to execute concurrent transactions so as to avoid their interference in each other's executions due to race conditions occurring for accessing the same data. There are various isolation levels supported by different databases. Example, DBs provide different isolation levels, such as serializable isolation to serializable isolation. There is a performance cost to implement isolation levels with stronger guarantees, such as strict serializability, which is yet another isolation level. And that performance cost is usually in terms of higher latencies in processing transactions. What's durability? Durability is the ability to preserve and persist committed data even in the event of software or hardware failures. And DBs persist this data in the non-volatile storage, such as hard drive, or they also provide durability through replication. So in case if one instance of the server fails, another instance of the server provides that requested data. So that was about that's it for ACID transactions. If you have any comments, questions, feedback, please post it, and thanks for listening.